All right, so you're all over here. So what I really want you to do is look at something called moles and not the furry little creatures. And I want to really talk you through this and build on, hopefully, things that we've done before. Or things you've done before. You're year 9 now, so I'm assuming you've done certain things. If you haven't, we can pull back. All right, so now moles are amazing. And there is something I write on the top of every year 9, 10, 11, 12. Not year 13, they know it by then. They're probably sick of me saying it. Okay, so in chemistry, you can never compare masses, only moles. I say that because sometimes you might get away with it, but honestly, those are very easy, rare questions. I'm talking about real chemistry that you guys are going to be doing. All right, you can never compare masses, only moles. So, what is a mole? A mole is a ratio, and actually, that's literally what it is. But what we're going to do today is learn how to calculate a ratio. Learn how to calculate a mole, a ratio. So, we're going to have a look at number one. I have got 90 grams of H2O. So what I'm going to do from here is the equation you need to know for calculating moles. It is moles equals mass. Now here's the thing, we'll be looking at using it. It's always in grams, all right? Divided by relative formula mass or MR, okay? Now what do I mean by that? And hopefully just as a refresher, all right? I'm going to put in RFM. Some people like to write MR. I like MR because it just looks like a mister, but there you go. What I like to do from here is really lay my work out. Now, the thing is, you need to know this formula, really, you really do. And my advice to you is every time you do a question, write it out. Or before you come to an exam, you're going to think, oh my God, I've got to read this a million times and try to remember it. How would I do question A? All right. Well, actually, I'm going to change it. I'm going to write out a completely different question just so you can use that to practice with. How many moles are in 36 grams of water or H2O? All right. So you've got all the formulas, which is you're going to need them. So water is H2O, and they've given it to you in all of it. So what I'm going to do now is use my formula. Moles equals mass in grams, well, that's 36, divided by the MR of water. How do I get the MR of water? Well, looking over here, it is made up of two hydrogens, hydrogen and a hydrogen and an oxygen. This is what water is made of. That's what those numbers mean. You now need their atomic masses. And you need to get the atomic masses from a periodic table. The one thing I want to say to you is a lot of students will Google a periodic table. You want to Google your exam boards or a GCSE. If you don't know your exam board, you probably won't year 9. Just Google a GCSE periodic table. Do not use anything else because different periodic tables are laid out in different ways. And I'm just going to put one here. All right. So in this one, hydrogen is here. You look at the number at the top, the atomic mass, that is 1. So I'm going to write 1, add 1 underneath my hydrogen. I need to add an oxygen. Well, oxygen's over here in group 6. And the big number at the top, the atomic mass is 16. I add all these together, 1 add 1 is 18. I now substitute that 18 into that MR. So my moles is 36. My mass hasn't changed. It's in grams. I'm happy with grams divided by 18. And that should give me the number of moles, which is 2. Always use a calculator. I do not care how easy the question is. We will never, ever not give you a calculator or a periodic table. All right? And that is how, year 9, you calculate moles.